plus 2 equals 7 to the x. So if we have an exponential, we are still checking to see if common base is an option. There were at least one, maybe two on here that worked. So if that works, it is the easiest way to get there. But if you can't, that's when we have to add a log. Now, you only add a log when you can do it to both sides of the equation. So that's something I caught yesterday. Some people were trying to add a log to one side only. We are adding it to both. The reason we like the log is because the properties of logs say the exponents can drop down in front. So now we can actually solve for x. Here we have to distribute this log 5. So the numbers just get multiplied in the front, so it's x log 5 plus 2 log 5 equals x log 7. We have two terms with an x. You need all of your x's on one side. So I'm going to subtract over the x log 5. Now both of these have an x, so what do we do? Okay, so now it's x times something. So to get x by itself, we divide. So it's 2 log 5 divided by log 7 minus log 5. I have been asking you, unless I say exact value, go ahead and give me the decimal equivalent, which is kind of nice on these because there are different ways that you might move things around, so it's easiest to check if our answers are equivalent. Remember, every time you push the log button, it opens a parenthesis, so you do have to close that. Another problem that I've been seeing, if you were just putting this in, you would need parentheses around the numerator and the denominator, or use the fraction feature on your calculator so you can view it as a fraction and make sure things are in the right spot. So if we do that, we get 9.566.
Instead of taking out the x, can't you just do x log 7/5?
If you're, yes, because you're kind of skipping a step, but yes, because the x's will go into the exponents, and so that means it's log of 7 to the x over 5 to the x, and then it's this to the x, and the x comes down, so yes, that is equivalent. Other questions? So problem 8. E to the negative 4x minus 1 equals 5 to the x. So we cannot get a common base. That means we add logs. A lot of times if we have e, as I've told you, natural log, it's not that it's the only answer, but it's just nicer. Because a natural log is log base e. And anytime you have the same base on your log and exponential, those just cancel. So that gives us negative 4x minus 1 equals x. This one doesn't cancel, so it still has its natural log. So when I look, I have x's in two spots. I need those on the same side. So I'm going to add over my 4x. Both of these have an x, so we factor it out. So now it's x times something. The opposite of multiplying is dividing. So we have negative 1 over the natural log of 5 plus 4. Again, if you're doing calculator, you have to close the log, or the parenthesis after the log, and you need the entire denominator in parentheses, or you need to use that function or fraction feature. And this gives us a negative 0.178. Alright, so we did have a lot of questions over those two yesterday. Are they okay now? Anything else on the front page that you want me to go over? question 11. Alright, this one there are several options. The easiest option, if you caught it, did anybody just look at log base 7 of 49 and know what that was equal to? What is it equal to? It means 7 to what power equals 49, which would be 2. So if you caught that, it's just 2 equals 3x minus 4. But if you didn't, you would change it into exponential. So it's 7 to the 3x minus 4 power equals 49. And then we can get a common base. 49 is the same thing as 7 to the second power. So if the bases are the same, you set your exponents equal. Did anyone do it the different way? Let's look at number 12. This one was ugly, just because the number was big. We have two logs, we have to condense them into one. If they are subtracted, how do I put them together? Division. So that would be x squared divided by 7. Now, anytime you only have a log on one side, what do we do? So 3 to the 12 equals x squared over 7. What would you have to do at this point? So 3 to the 12th is a very large number. And then we have to take it times 7. And then how do you get rid of the square? No. With that, you have to do plus or minus. And so we get 1928.7527. You have to be able to check these. Now technically, if I put it in right now, it's an x squared, and they would both work, but the properties of logs still have to hold. And properties of logs say that 2 has to be able to come down in front. So if I have to be able to drop the 2 in front, x has to be a positive number. So it is just the positive. But don't get in the habit of always assuming the x is the positive answer. You know, if this had had an opposite of x right there, then the negative one would have been the one that worked. So take a second and actually check them. We're just looking at when we have logs in the original problem, the argument has to be a positive number. Is that okay? Alright. Here I see I have logs on both sides. So what I want is just a log. I don't want that 2 in front, so I can take it up into the exponent. Dividing doesn't really help me since it's another log over here. It would just move it to the denominator and then I'd still have to change it. Once you have a log on each side, properties say you can drop those logs. So if it's only a log on one side, we use the definition. If it's on both sides, we drop them. So I can subtract over my 7x, add over my 12. factors into x minus 4, x minus 3. We set those equal to 0, we get 4 and 3. We have to check. 7 times 4 minus 12 is positive. 7 times 3 minus 12 is positive. So they both work. Questions on that? Does everything have a log on this one? No. So if we have terms without a log, our strategy is to change it, use the definition to go to exponential form. Before we do that though, we have to have just one log. So I have to condense these. Those logs are added. So when we put them together, we multiply those arguments. So that gives me x squared plus 7x plus 12. Now, since the log is on one side, we go to exponential form. So 2 to the first equals x squared plus 7x plus 12. 2 to the first is just 2, so we can subtract that over. Multiply to 10 and add to 7 would be 5 and 2. Except this equal to 0, we get negative 5 and negative 2. And then we have to check, going back to the original, the arguments have to be positive. Negative 5 plus 3 is not positive, so the negative 5 is out. Negative 2 plus 3 is positive, negative 2 plus 4 is positive, so that one works. So negative 2 is our only answer. Are you guys seeing the difference on the different log problems? We always use properties to condense as much as we can. And then if you're left with one log on each side, you drop it. If the log is only on one side, you change to exponential. So 15 is okay with everybody?
Mhm.
Okay, 16. So ln, that's just natural log. It's the same thing. It's just log base e. Comes up so much that it has its own abbreviation, but all of our rules are the same. If you have two logs being subtracted, how do we combine those? Division. Okay, and when we look on the other side, we have the same thing, two logs subtracted. So we divide. Now if you have a log on each side, you can drop it. So our arguments are equal. What do we have to do at this point? Remember when you cross multiply, there's an equal sign in between. Several people yesterday were cross multiplying and writing them as a fraction. When we do that, 5 FOIL those, we get x squared plus 2x minus 3. Then I multiply those two, so x squared plus 4x minus 12. If I subtract over my x squared, those cancel. So if I subtract my 2x, add my 12, divide, we get 9/2. You have to check 9/2 is 4.5. So 4.5 minus 1 is positive, plus 6 is positive, 4.5 minus 2 is positive, plus 3 is positive. So that's my only answer. So I'm asking for the change of base, and I told you you must show work. Okay, so I have to know that you know how to do this. If you really get confused, you could set it equal to x and just solve it like we did the others. But if you remember the change of base, it's just log of the argument divided by log of the base. So that's all the work you have to show. Type that in. And get the 2.1534. But like I said, if you forgot it, you set it equal to x. So it's 5 to the x equals 32. What would you do at that point? What would we have to add each side? Log. And then the exponent comes down. And then you just divide. So we get to the same point. That's where the change of base formula comes from. But if you forget it, just set it equal to x, change it to an exponential, and solve this. 18 was okay with everybody? 19. Find the doubling time. So we are looking for time of an investment compounded semi-annually. So first of all, it's not continuous. That tells me I'm using this formula. It also tells me N. N is the number of times a year. Semi-annually is how many times per year? At an interest rate of 3%. So remember your rate, you always have to change it to decimal form. So 3% would be 0.03. Okay, I did not give you P or A, but I said find the doubling time. So if I started with 100, what would I have to end with? 200, because I wanted the time it takes to double. If I said triple, then you would end with 300. So if we plug in, make sure if you didn't have this correct, you are fixing it as we go. What would we do here? Between the two. 1 plus 0.03 over 2. 1.015. Okay, we are trying to solve for an exponent. We're solving an exponential. Is common base an option? No. So what do we do if we can't get a common base? When we do that, any exponents drop down in front. We've had quite a few problems like this, and we're still people getting confused. This is all multiplied together. So if I want to get t by itself, I can just divide by the 2 and the log 1.015. Okay, when you put that in, make sure you do parentheses around the entire denominator. You should get t to equal 23.27777, so 2 3 years. Um, 20 and 21 were standing and condensing, so we didn't ask any questions about those. You can handle that. 22, the domain. We didn't ask about it. They're not hard, but we need to maybe jog our memory. All I'm asking for with the domain, and we're doing it on every problem that has a log. I'm always saying check it. And I keep telling you, the argument has to be positive. So on these, it's just the thing in parentheses greater than 0. So x is greater than 3 halves. You know I always want those in integral notation, so greater than 3 halves would be 3 halves to infinity. On B, it doesn't matter what the base is. It doesn't matter if there's something else on the outside. All we care about, thing in parentheses, is greater than 0. So if I subtract my 8, dividing by a negative flips my inequality, so x is less than 8 fifths, so that's negative infinity to 8 fifths. So it's not the math that's hard on that, you just have to remember the rule, and we're using it every time we solve those equations and check our answers. The argument has to be positive. Let's look at 20. Let's get a junior from that. So I would give you the pH formula. So it tells me to find the hydronium ion concentration. So I'm solving for this of a solution with a pH of 8.6. So my pH is 8.6. Divide the negative over. What is the base of our log? 10. So if we change it to exponential, it's 10 to the negative 8.6 equals H3O plus. But that's not how I want you to write your final answer. If you type 10 to the negative 8.6 power in your calculator, it's going to depend on which calculator you're using. If you have the graphing ones, it just gives you the answer. But we know on the test we don't have those. So it has something like this. Can you put it in? So we need to move our decimal 7, 8, 9 places to be right there. So that's 2.5. To move the decimal 10 places, you're multiplying by 10. We moved it to the right, so negative 9.
Where does your 10 come from on this?
That's what moves, since just kind of how our number system works. If you multiply by 10, it moves the decimal, it adds a 0. The negative is just moving it backwards.
So it'll just be like times 10 every time.
Every single time. Yep. Yes, ma'am.
When I plug 10 up to the negative 8.6, I got like a different number than that.
Oh. To round to more. It already rounded because it was only showing that many settings. Yeah, it's just these only show that many. So if that were the case, if you said 3.0 times 10 to the negative 9
Okay.
on those calculators, that's what it's giving you. It's because they're set to only show so many digits, and that just had more digits than it would show. Are we okay there? So 24. If I'm asking you to graph this, we first change it to exponential form. So it's 4 to the y equals x. We graphed exponentials on our last test. And we always put in -1, 0, and 1 for the exponent. Since my exponent is y, that's where I'm putting my -1, 0, and 1. So 4 to the -1 is 1/4. 4 to the 0 is 1, 4 to the first is 4. So if we plot this, 1/4, -1, 1, 0, 4, 1. Remember, logs always have a vertical asymptote, so it should look like that. I'm going to do these a little out of order. I want to do C next. Because you notice this is still log base 4. So the one I just graphed is your parent function. So 1041, that's my parent. Think about transformations. What would this plus 1 do to my graph? If you move left or right, you have to move your vertical asymptote. So now we have a vertical at -1, and we just move each of these points to the left. So it should look like that. So B, we have 1/4 to the y equals x. So -1, 0, and 1 go in for y because it is our exponent. 1/4 to the -1 is 4. 1/4 to the 0 is 1. 1/4 to the first is 1/4. Remember, they always have a vertical asymptote, so you are not crossing that vertical line. Is that okay? So let's talk about 25. I know we only asked about one of them, but we have a few minutes, so I'm just going to kind of run through the list here. I'm asking you to evaluate them without a calculator, meaning I'm asking you to think about what a log means. A log is giving us an exponent. So when I say log base 3 of 81, you can, if you want, set it equal to x and solve it like that, but all it's saying is 3 to what power equals 81? And what would that be? Okay, if you got confused, you could always do this and say 81 is 3 to the 4th, so x is 4. So B, log base 3 of 1/3 means 3 to what power is 1/3? So all you did is move it to the bottom, so that's -1. C, log base 10 of 0.01. Alright, if you struggle with that, 0.01, that's called 100. So that's 1/100. We know 10 squared is 100, but since it's on the bottom, it would have to be -2. D, log base 6 of the square root of 6. That's saying 6 to what power equals the square root of 6? If you're not sure, remember, square root is just a 1/2 power. We know log base 6 of 6 would cancel, so it's just 1/2. E, log base e of 1 means e to what power equals 1? And we know anything to the 0 power is 1. So these logs, you can work them out, or you might be able to just look at them and know. F is probably a little bit harder. So this one, let's go ahead and just work it out as an equation. So if I set that equal to x, it means 3 to the x equals 27 to the 3/2. So this would have been the question on our last test. We would get a common base. 27 is 3 to the 3rd power. We know a power to a power we multiply. So that would be 9/2. So then f